Okay, so now you've watched the lecture on measures of central tendency and you've attempted the practice problems at the end of the lecture slides, and now it is time to get the answers to those practice problems at the end of the slides. So let me go ahead and walk you through the best way to find all of the answers to all of those problems. So this first question, you're looking at a frequency distribution table that represents data of how many NSC psychology majors took a certain number of semesters to graduate. So, the hypothetical situation is that at graduation, you ask all psychology majors how many semesters they were in college before they graduated. So if we just look at this frequency distribution table, remember this first column represents all the values represented in your data set. And then the second column represents how many times each one of those values appeared. So in other words, if we look at the top row, we know that 3 students spent 15 semesters getting their degree. And then the next row, 5 students spent 14 semesters getting their degree, and so on and so forth. So for that first question, you're asked to find what is the mean number of semesters psychology students take at students at NSC take to graduate. And we're working with a population right now, so we're going to use population notation. So mu, the population mean, is equal to the sum of x divided by uppercase N, representing the population size. So we need to find 2 pieces of information to calculate the mean. We need to know the sum of x, and we need to know the population size. Now, that is not as easy as it might appear, because you may be inclined to just add up all of these x values and say, oh, that's my sum of x. But if you've been practicing doing calculations with frequency distribution tables, hopefully you're quick to remember that you need to take each frequency for each value into account. Because think about it, if you wrote this data out in raw form, I'm not going to do it all because it would take me a while. But so, okay, 3 students had 15, so 15, 15, 15. 5 students had 14, so 1, 2, 3, 4, 5, and so on and so forth. Now, if I wrote all those numbers out and I needed to find the sum of x, I would add all these values together. Well, instead of doing all of that, I can take into account that there are 3 15s in my data set using the simple form of the frequency distribution table and multiplying 15 by 3. That gives you the same thing that you would get if you added 15 plus 15 plus 15. So this is just a shorter way to do it and avoid writing out all of your data in raw form. Okay. So again, we have to take the frequencies into account to find the sum of x. So I'm going to create a new column, xf, because you need to multiply each x by its frequency and then add those values together, and what you get is the sum of x. So let's go ahead and do that. So the first one, we've got 15 times 3, we've got 14 times 5, 13 times 9, 12 times 9, 11 times 8, 10 times 5, 9 times 3, and then 8 times 2. And hopefully you see where I got those numbers from. The first row, 15 times 3, the x times the f. So then I'm just going to do all of these multiplications. So 15 times 3 is 45, 14 times 5 is 70, all the way down. So 117, 108, 88, 50, 27, and 16. You add all these values together, each x times each f, add those together, and you end up with the sum of x of 521. So now I can plug that into my mean formula down here, 521. But remember, when you find the mean, you add up all the scores and then you divide it by the total number of scores. Well, how many scores are in the data set? Well, you already know that there's 44 because I've told you that. But you could find that by adding up your frequencies. So your sum of f is equal to your population size, which is equal to 44. So if you add 3 plus 5 plus 9 plus 9 plus 8 plus 5 plus 3 plus 2, you end up with 44. those two things are synonymous with each other, the sum of f and the sample or population size, if you're using a frequency distribution table. Another way to state the sum of x, if you're using a frequency distribution table, would be the sum of fx. Those two things are synonymous with each other because you have to take each frequency multiplied by each x value if you're using a frequency distribution table to end up finding the sum of x. These both mean adding all the scores together. These both mean the total number of scores in the data set. So 521 divided by 44 is 11.841, and that is the mean. Okay, so now let's use this data to figure out the median number of semesters that psychology students at NSC took to graduate. So if I look at this data, I already know that I have an even population size. So when you have an even number of scores, you're going to have two midpoints, and then you just find the mean of those two midpoints, and that is your median. So the first thing that you need to do is put your scores in numeric order. I already have done that, because if we're trying to find the midpoint, the scores need to be in order, but the frequency distribution table does that for you. So the next step is to find the median index. So I equals n divided by 2. Remember, we want to split those scores in half, right, to find the midpoint. What two scores in this case are where 50% of scores are above and 50% of scores are below. Okay, so the median index, n divided by 2, 44 is our population size. Divide that by 2, you end up with 22. So we need to have the 22nd score and the 23rd score to find our median. So the formula that we will use in this case, so for the median, because we do have an even number of scores, so the ith score, which in this case is the 22nd score, plus ith score plus 1, so 22 plus 1 is 23rd score, divided by 2. So what is, and let's go ahead and just rewrite this, the 22nd plus the 23rd divided by 2. That's not 22 plus 23 divided by 2. That just tells you the position of the scores, not what the score actually is. To find what the score actually is, you have to consult the frequency distribution table. And you have to focus on the frequency column, and then that'll help you identify what score is at that location. So the 22nd score. You can start from the top or the bottom. It doesn't matter. You'll land on the same two scores. Let's go ahead and start from the top. So the first three scores, starting from the high end, are 15. Then the 4th through 8th score are 14. Then the 9th through 18th score are 13. Then the 18th through the 27th score are 12. Well, 18th through the 27th score (22) and 23 both fall between 18 and 27, so you know that your 22nd score is 12 and your 23rd score is also 12. Divide that by 2, you end up with 24 divided by 2, and you get a median of 12. But if you go the other way, you'll land in the same place. So if we start at the low end here. So first and second score are 8, 3rd through 5th score are 9, 5th through 10th score are 10, 10th through 18th score are 11, 18th through the 27th score is 12. You still end up with two 12s. Now let's look at the mode for the distribution that you see up here. So whenever you have data that's presented in a frequency distribution table, you can identify the mode pretty quickly by looking at the frequency column, finding the highest frequency or frequencies, and then looking to see what value those frequencies correspond with. So if I'm looking at the frequency column, I can see that the highest number is a 9, and there's two values that have a frequency of 9, 12 and 13. So my mode in this case is equal to 12 and 13. So I have a bimodal distribution. Two modes. But we need to plot our data in a frequency distribution graph to know if the shape is approximately normal or if it's a skewed bimodal distribution. So the reason that we do that is because we need to identify the most appropriate measure of central tendency. And remember, that depends on the scale of measurement and the shape of the data. So if the scale of measurement is nominal, you automatically use the mode. If the scale of measurement is ordinal, you automatically use the median. But if the scale of measurement is interval or ratio, you have to figure out what the shape is to decide what measure is appropriate. And if you think about number of semesters, that is definitely either interval or ratio. And then you have to think about, okay, is there a true 0 point? So you know it's interval or ratio because not only do you know that some values are greater than or less than others, but you know by how much. So for instance, if somebody attended 10 semesters of college to graduate, you know that they attended one less semester than somebody who attended 11. Not only do you know it's less, you know how much less. But then you have to think about that true 0 point, because if there is a true 0 point, then we can say it's ratio instead of interval. If somebody said 0 semesters, then that means a complete lack of semesters. That's a true 0 point. You can't have negative semesters. I'm going to call this ratio variable. So remember, I said if it's interval or ratio, you have to consult the shape of the distribution to know what measure is most appropriate. Because not every measure of central tendency is appropriate for every situation. It depends, again, on the scale of measurement and the shape of the data. So I'm going to go ahead and draw a histogram because this is ratio data. I could draw a polygon if I wanted to, but I prefer histograms. So I'm going to do a histogram. So my x-axis needs to be labeled number of semesters. And then I'm going to present the values for number of semesters from lowest to highest, left to right. So our lowest is 8, goes all the way to 15. So 8, 9, 10, 11, 12, 13, 14, and 15. And then the y-axis, the vertical axis, represents the frequencies, which in this case is the number of students. So make sure if you're actually given value or given labels for what the data represents, you don't just have X and F, but you know what X is and what F is. When you go to label your graph, make sure that you provide the label that's most descriptive. Don't just put X on the X-axis and F on the Y-axis. So we look at our frequencies and it goes from 2 to 9. So I'm going to go ahead and count by 2s on my frequency. So 0, 2, 4, 6, 8, and 10. So I go to my value of 8 on the x-axis, and then I draw a bar that goes up to the frequency for that, which is 2. Now remember, with your histogram, your bars touch, so make sure that your bars touch in your graph. So for 9, we had 3 students at 9 semesters. We had 5 students at 10 semesters. Now this isn't perfect, but I'm trying to make sure that my bars are halfway above and halfway below each value here. Okay, so for 11, 8 students said 11. For 12, there were 9 at 12. 13, also 9. 14, we had 5. And then 15, 3. So if I'm trying to identify the shape of this distribution, we kind of draw a line over it. It's looking pretty darn normal to me. It's not perfect, but it's pretty close. Yes, it's bimodal, but it's also normal. The two modes are right smack dab in the middle, and then we have gradually decreasing frequencies as you go out to the left or the right. Now we could have predicted the shape of this distribution based on the measures of central tendency. So the mode was 12 and 13, the median was 12, and the mean was 11.841. Well, remember, when you have an approximately normal distribution, your measures of central tendency, your mean, median, your mode, will be pretty close to one another. So you could have anticipated this. So when we have interval or ratio data that's approximately normally distributed, we always want to opt for the mean. The mean is our favorite measure of central tendency because it uses all the scores in the data set. It's the point of reference for measures of spread, or in other words, variability, and it's the foundation of hypothesis testing. But remember, you can't always use the mean. Sometimes it's not appropriate when you have skewed distributions or you have data that's on a nominal or ordinal scale. All right, so now let's look at a situation where we have sample scores that are presented in raw form. They're not in a table. And let's say you are asked to find the mean number of semesters of a sample of psychology students that came from the NSC Society for Psychology. So out of all of those 40 something, 44 students who were graduating that year who were psychology students, 5 of them were in the Society for Psychology. So what is the mean number of semesters? Well, now we're talking about samples. So the symbol for the mean is an M instead of the mu. And it's still sum of x divided by n, but it's a lowercase n representing the sample size. Well, in this case, we simply just add the scores that we see there. We don't have to take frequencies into account because every single score is represented right there. So we add 8 plus 13 plus 9 plus 10 plus 11, and you end up with the sum of x of 51. And we know that n is 5, but we also can count 1, 2, 3, 4, 5 scores. And 51 divided by 5 is 10.2. That is our mean. It's always helpful if you circle or highlight or square your final answers, so it makes it easier to find. Okay, the median number of semesters that this sample attended college to graduate. So this is a situation where we have an odd number of scores. So when that's the case, we're going to have a single midpoint. We're not going to have to find the mean of 2 midpoints to get the median. So if I look at this, I know I've got an odd number, I'm going to have 1 midpoint, and I know that the first step that I need to do is put these scores in numeric order. I can't just go, oh, that's the middle, right? 2 scores above, 2 scores below, because those are not in numeric order. So let's do it. So 8 is the lowest, and then 9, 10, 11, 13. Now I can pretty quickly identify that's the center. When you have a few scores, it's pretty easy to find the median. But let me walk you through using the median index to do it, just in case you have a situation where it's not quite so obvious. So I is equal to n divided by 2, using lowercase n in this case because we are working with a sample. There's 5 scores. Split that in half, you end up with 2.5. Then you round that up to 3, you're looking for the third score. And remember, you can start at the low end or the high end to find the third score. You can say, okay, first, second, third, or you can go the other way, first, second, third. You land on the same spot. So, our median is 10. So if we look at our mean was 10.2, and then our median is 10. I might be thinking maybe we have a normal-ish distribution, but I'm not sure yet. Let's find the mode. Well, guess what? Every single score occurs one time. So there is no most frequently occurring value. There's no mode. So now I might be thinking this may be more of like a rectangular distribution because there is no mode, and in fact, every single value occurs the same amount of times. So just for practice, I'm going to go ahead and draw out this distribution because we know already that this is ratio data, so we need to figure out what the shape is to decide which measure of central tendency is most appropriate. So if I draw my y-axis and my x-axis, we've got the number of semesters on the x-axis, and then the number of students, or the frequencies. And the lowest is 8, goes all the way to 13. So 8, 9, 10, 11, 12, 13. And 0, 1, 2. So 8 occurs once. I'm drawing a histogram. Remember, it's ratio data. 9 occurs once. 10 occurs once. 11, we have one 11, no 12s, and we have a 13. If I tried to draw a line around this, it's rectangular. So we can go ahead and use the mean in this situation. And that's because, if you look at this, we've got rectangular distribution and we've got a ratio scale of measurement. So the best number for describing this data would be 10.2. And that's pretty accurate. You know, we've got two scores that are slightly below 10, and then one score that's slightly above 10, and another score that's more above 10. So 10.2 represents that trend in our data. So I hope that you worked through these and got most of them correct, but if not, that's okay. Now is a great time to make mistakes. Nobody expects you to be perfect the first time you practice these things. And hopefully, through making mistakes and then learning the correct way to do it after watching the video, you won't make the same mistakes again.